There are a number of different types of ways to solve equations using what's known as an iteration process. So iteration just means doing something over and over again until you get close to the answer that you want. The simplest of these methods is called trial and improvement. What we have to do is we're trying to get as close to 7 as possible, accurate to 1 decimal place. So that's the x value that needs to be accurate to 1 decimal place. That's what we're looking for. So the first thing that we need to do with a trial and improvement here is get some idea of what possibly that value could be. Sometimes, if you're lucky, they might tell you that the value lies between 2 particular numbers. But if it doesn't, they don't usually give you a very big number. It's usually easy to guess. And we're going to work it out by just looking at the left-hand side here and substituting in some values of x till we work out one that's roughly the right size. So if you put in x equals 1, you'd have 1 cubed, which is 1, minus 2 times 1, which is minus 2, that's minus 1. If we put in the number 2 for x, we get 2 cubed, which is 8, minus 2 times 2, which is 4. 8 minus 4 is 4. If we put in 3, we get 3 cubed is 27, minus 2 times 3, which is 6, and that gives us 21. So what we can see is that the answer is meant to be 7, and that lies between the 4 and the 21, and so that means that our solution lies between x equals 2 and x equals 3, and what they're asking us to do is to find that more accurately, namely to 1 decimal place. Therefore, we're expecting our answer to be x equals 2 point something. We're going to start by trying x equal to 2.5 because that's exactly halfway between 2 and 3, and that will enable us to knock out a whole range of answers. 2.5 cubed minus 2 times 2.5, 10.625, but it doesn't really matter. It's bigger than 7. That's the important aspect to this. And so what that means is our answer must be between 2 and 2.5. I'm just going to go for 2.4 as my next trial. So let's bring the calculator back, and so what we're going to do is we're just going to change that to a 4 and go back and change the other bit to a 4. Evaluate that. Let's see what that is as a decimal. So that's brought it down to 9 point something, but we're still not there. So let's try 2.3 instead. Bring the calculator back. 3 there, and back we go. Well, that has got us a lot closer, but still not there. 7 point. So by 2.2. That, whoops. Want. Okay, and then go back and change the other one. That gives us 6 point something. Okay, so that tells us that our answer is between 2.2 and 2.3. So one of those two is going to be our answer. But in order to determine which one it is, we're going to go halfway between both of those. So we want 2.25 as our last attempt. So again, let's go back here. So I'll add a 5 there. 5 there, and That gives us 6.89, which is too low. So that means our answer must be bigger than 2.25, and therefore our answer is going to be 2.3. Another way of just looking at that, 2.2 here, 2.3 here, 2.25 here. This one is too low, this one is too low, this one is too high. So the answer must be somewhere in here, but all of the answers in that section would round to 1 decimal place. They would round to 2.3. So that's trial and improvement. Sometimes you're not asked to actually solve as such, you're just asked to prove that there is a solution. So this is how we do it. So we're going to substitute in x equals 6 and x equals 7 to start with, and then I'll explain how that tells us if there's a solution or not. But when x equals 6, we're going to type in 6 squared minus 4 times 6 equals, and that leads to 12. Do the same now for 7. Back 6s for 7s. Then now we're getting 21. So how can we say that that shows that there is a solution between 6 and 7? Well, we're told that when we substitute the values in, it's supposed to be 13, and the number 13 lies between 12 and 21. Therefore the answer must be somewhere between 6 and 7. So here we have a different type of iteration question. So in this question we've been given a formula to use, and we're trying to get an answer accurate this time to 2 decimal places. So we've got an equation, x cubed minus 4x equals 5. That's what we're trying to find a solution to. And we've got a little formula that we're going to use to actually get that approximate solution. So we've got subscripts here. Okay, so these are labels, these are not powers. And over here you can see another example here, and that's 0. If xn is x0, then xn plus 1 would be x0 plus 1, which is 1, and so on. Okay, so the xn plus 1 and the xn just mean that they're consecutive in this sequence of approximations that we're going to do. Sometimes they give you x1 instead of x0. It's fine. This is your starting point, and this is what we're going to substitute into this formula instead of the xn. And again, we're going to do this using a calculator. So we've got x0 equals 2. We're now going to find out what x1 is with the aid of a calculator. So we want the cube root, so we need to shift to get that, and then we want inside there, we want 4 times 2, in this case x0, plus 5. Let's find out what that gives us. So that gives us 2.35133. I'm going to write down 2.35133. You want to write quite a lot of it down as you go along. So now we're going to substitute that new value, the x1 value, into the formula so that we can get x2, the next one up. And I'm going to show you how we can use the calculator to do this nice and easily. And on our third step, it's going to get even easier still. So we're going to go in here, and what we're replacing is the 2 that's in there. Whoops. But what we're going to replace it with is answer, which was the 2.35133 that we had before, and press equal. and that gives us the next version. So 2.43318, I'm going to write down 2.43188, I think that's it. Okay, oh, 3318, let me change that one. So now we're going to go for x3. Okay, we need to keep going. We're trying to get it accurate to 2 decimal places. So one of the things I'm going to do now is put a line sort of here where the two decimal places ends. And what we're looking for is to start to get values of x that when rounded are exactly the same to 2 decimal places. So we need to keep going a little bit further at the moment, but it now becomes very easy to do on the calculator, because all you have to do now is just press the equals button and it'll get you the next one. Next one is 45147. Getting closer together but still not there, so let's go for x4. So going back to get x4, 0.45552. So we're beginning to get close, I think, but we need to go again. So x5, 2.45642. Okay, so we've got 2 now, x4 and x5, both round to 2.46 to 2 decimal places. I'm just going to try one more just in case. It doesn't take much effort to do on the calculator, as you can see. So that's 5662. So definitely we can now see that each of these 3 here to 2 decimal places round to the answer 2.46. So that would be our approximate solution. So the iteration formula that we used in the previous example comes from rearranging the equation that we're given to start with, and so that might be part of one of these questions. So let's just go through it. So here they've given us an equation, 5x squared minus x cubed plus 5 equals 0. And we've got to show that we can rearrange it to get x equals 5 plus 5 over x squared. So that gives us a clue that we're going to need to divide so that we end up with that x squared on the bottom. So let's divide everything through by x squared. So 5x squared divided by x squared would leave us with just 5. X cubed divided by x squared will leave us with x. And then we'll have 5 divided by x squared. And 0 divided by anything is not going to change. So you can see we're very, very close here now. So all we've got to do is add x to both sides to get x on its own. Technically that will have it the wrong way round, but that's just a writing exercise. You can just rewrite it to show it that it's the same the other way round.